Hello students and welcome to the lecture. So students, as we know that we have been covering the key national institutions and we had started with the ISRO in the previous lecture. We had discussed some facts about the ISRO. I hope that you have revised these facts before you have come for this lecture. Basically, in this lecture, we are going to continue with the ISRO and we will look upon the other facts related with the ISRO. So if you haven't revised the previous lecture, it might be difficult for you to grasp the facts which we are going to discuss. And if you have revised the lecture previous before you have come for this lecture, then it is for your own benefit. Okay. So with this note, let's start this lecture. So basically, now we are going to cover with the key objectives and the function. Like in the previous lecture, when we were discussing about the ISRO, I had told you it was established in the year of 1969, and who was the person who initiated the process? So he was Dr. Vikram Sarabhai, right? And he is famously known as the father of Indian space program, right? Also, we had discussed about INCOSPER, right? So all these things we had discussed. Now why I'm trying to connect these things with this thing? Because if you have revised them and if you had listened the lecture properly, you are well aware that what is the work of ISRO and what is its vision. Okay. So right now we are going to discuss about the fact that the primary objective of ISRO is to develop and deploy the space technology for various applications like the communication, remote sensing, navigation, meteorology, and the scientific research. About communication, how does satellite help us? We had discussed. About remote sensing, how does they help us? We had discussed. Now, what about the navigation? So basically, I think that all of you must have used the Google Maps in your life. If you're having a smartphone, you must have used the Google Map. Now, if I'm generally ask you, what does the Google Map do? Then how will you answer it? Basically, Google Map tells us the way, right? But the question is all the information regarding the way, regarding the roads, highways, crossings, all the information already stored in the Google Map? And if it's so, then how much the storage should be, right? So basically, Google Map is a real-time map. And what does it mean? It means that no information has been saved in the Google Map storage. Actually, it is working on the satellite-based phenomena. Satellite-based phenomena. How? Let me show you. Suppose this is you, okay? And you want to go to your friend's home, which could be anywhere in these streets. Okay, so what you have to do? You just have to ask for the location of your friend. Okay, and once he share the location with you, suppose he is there. Okay, thereafter, when you click on the location, you get a way to reach your friend. So basically, this is possible because of the satellite present in the space. How? When your friend shares a location with you, the satellite catch the data from your friend's mobile, okay, on device from which he is giving the location. The information then process and share with you on your device on which you are using the GPS application. And thereafter, you find a way to reach your friend like this one. All right, that's how the navigation system works. And this is just an example. It is a very broad term. Okay. Thereafter, if we go for the meteorology, go for the Meteorology. So basically it's an atmospheric phenomena. So basically the satellites which are in the space could be used for the meteorology. It means to understand the atmospheric circulation and atmospheric activities for prediction of storms, tsunamis, tornadoes, whatever natural calamities could be. These all the things could be done. Okay. So these are one of the key objectives of ISRO. Second, ISRO is involved in space exploration mission, including lunar and interplanetary missions aimed at expanding our knowledge of the cosmos. So basically, we had found words like cosmos, like interplanetary, like lunar. What does they mean? Let's discuss. So if we start discussing them one by one, first is the lunar. Basically, lunar word is here used for the moon. Okay. And when we talk about the lunar mission, it is basically related with the mission to moon. Okay. Thereafter, if we talk about the interplanetary missions, it means interplanetary missions. Then basically they means missions on other planets. For example, Mars, Neptune, Jupiter. So if you have seen a Hollywood movies, then you must have seen there are so many movies based on this kind of missions. Okay. Thereafter, cosmos. Basically, cosmos here is used for the universe, or in short, you can say for space. Okay. So basically, ISRO, which is slated for the space research, it's definitely involved in this kind of missions to study the moon, to send the missions on other planets, to study them, to have a understanding of the universe. Okay. The agency collaborates with various national and international organizations to promote global cooperation in space-related activities. Because there is a wonderful thing, 100% things could not be obtained by only one party. It is a true thing. It means that cooperation is required because no one could do the things 100%. Okay. So that's why suppose if we have the ISRO and if we have XYZ, they both are the space agencies. Okay. And we were doing the interplanetary missions. Somehow ISRO is able to reach the M, but XYZ is not able to reach the M. Okay. But ISRO failed to reach the A, whereas XYZ succeeded in reach the A. So in this scenario, if we share our technology of M to XYZ, we could have a technology of XYZ about A, right? So this is the collaboration, which is done with the national and international organizations to promote the global cooperations because, however, we are divided in the nations, in the countries, but our earth is one. Okay. That's why when it's come to the cosmos or come to the universe, then we have to think it from the perspective of one earth, not from the perspective of various countries and nations, you can say. That's why global cooperation is very much required. Now, launch vehicle development. Now it is very, very interesting topic. Actually, ISRO has developed various launch vehicles, including the Polar Satellite Launch Vehicle, in short PSLV, and Geosynchronous Satellite Launch Vehicle GSLV to deploy satellites into orbit for various purposes. Now, this thing I would like to discuss with you in depth. Suppose this is our Earth. This is our Earth. Okay. Now, if you want to develop the satellite here, okay, outside the Earth's atmosphere, outside Earth atmosphere, then you are not able to just throw it, right? It means that one day you made a satellite and then you use the caterpillar to throw the satellite out of the Earth's atmosphere. It is not possible. Why? Because Earth's having a gravitational pull, which is very, very strong. Okay. So if you try to launch the satellite in the upward side, the gravitational pull will try to grab it in the downward side. Okay, so if you really want to launch the satellite, you are required a technology to counter this gravitational pull, and that's why the launch vehicles required. Okay, so basically, if we talk about what do we mean by the launch vehicles, then if you ever watch a launch of the satellites from your TV, from movie, from whichever the sources you are using, so you have noticed it, like it is look like this one. This is the design. Okay. So there is a something like this type of rocket. Okay. Basically, you can search the launch vehicle on the net. Okay. My drawing is not so good. So this kind of launch vehicles in which this is a rocket, this is a satellite, and this is basically the stage engines. Right? So these launch vehicles are basically responsible to carry the satellites and counter the Earth's gravitational pull till the place where there is a less gravitational pull from the Earth side, and then we can place the satellite into the orbit. Okay, remember we have to place the satellite in the Earth's orbit, then only it will start revolving around the Earth. Okay, if somehow the satellite cross the Earth orbit limit, then you know what will happen. The satellite will lost in the universe, because in the universe there is a vacuum and no one knows what will happen with the satellite and where it will start revolving. Okay, actually we know the satellite will disappear, but as I have told you, it should not be able to cross the Earth's gravitational pull. If it's cross, it means that the satellite is lost in the space forever. All right. So now we have two types of launch vehicles. First is the polar satellite launch vehicle. Second one is the geosynchronous satellite launch vehicle. So basically there are two types of satellites: low orbit and geostationary. Okay. So if we talk about the low orbits, then basically they are nearly about 800 kilometers to 1000 kilometers above the Earth's surface. Okay. If we talk about the geostationary, then they must be at the distance of 36,000 kilometers from the Earth's surface. Now you can see what is the difference between their distances. Okay, so when you required a low orbit satellite, then you required the polar satellite launch vehicle, and it is of the less fuel consumption, because it is only going to cover the 800 to 1000 kilometers distance. But when you required a geosynchronous satellite launch vehicle to launch the satellite at 36,000 kilometers height, then you required a high consumption fuel, and it is also the powerful because it is going to cover the huge distance. So remember, geosynchronous satellite launch vehicle and the polar satellite launch vehicle, and why they are used. PSLV for low orbits, and then geosynchronous for GSLV for geostationary. Okay. Now, if we talk about their uses, then basically low orbit satellites could be used for navigation. Okay. They could be used for meteorology. Okay. Wherever we talk about the geostationary, then they are uses for TV communication and other communications. All right. And if we talk about the orbital speed, it means that how much time they take to take the one revolution around the Earth. Then basically low orbits required 85 to 100 minutes to take one revolution around the Earth, whereas geostationary required a 24 hours, or you can say they basically move with the Earth's movement. Okay, that's why they are called as a geostationary, because whenever you see them, you find them at one place, because they are revolving at the same speed as the Earth revolves. Okay, that's why they require 24 hours to complete the one revolution, whereas low orbits requires only 85 to 100 minutes to complete the revolution. Okay, now these successful deployment and operationalization of these launch vehicles have positioned India as a cost-effective and reliable launch services provider in global space industry. Basically, not only the making of launch vehicles and satellites important. Satellites important, but it's also important that they must be cost effective. They must be cost effective. Okay. And India, or you can say the ISRO, is one of the best choices to launch satellites in the space in cost-effective manner. For example, suppose if there is a country XYZ or organization XYZ, if they are launching the same satellite in 100 crores, then ISRO, by its cost-effective technology, could launch this satellite in only 80 crores. So it means that if we are going to capture the global space industry, we having a best offer for our customers and for our service seekers. Okay. Now the satellite deployment. ISRO designs, develops and launches a variety of satellites, including the communication satellites, Earth observation satellites, navigation satellites and scientific research satellites. And basically These satellites have played a crucial role in improving communication services, enhancing agricultural and environmental monitoring, and enabling disaster management among other applications. Why? Because they 24 into 7 keeps their eyes on Indian land and nearby territories. Okay, and they're not only keeping their eyes but also studies the different activities going on. That's why these satellites have played a very crucial role. So basically, if we're talking about the satellite deployment, then we must talk about the year of 1975. In that year, what was happened? Why I'm saying that we should remember this year? Because during this year, there was a satellite launch of Aryabhat. Okay, so Aryabhat was basically first indigenous satellite launched by ISRO, or you can say India. But remember one thing. And what was that thing? It was launched with the help of USSR by using their Cosmos 3M rocket. Okay, and if we talk about the launch site, then launch site was Kasputin-R. Okay, so basically it was the year of 1975 when the ISRO got succeed to made the India's first indigenous satellite, Aryabhat. But as I have told you, satellite making is an another thing, but launching it is an another thing. You have made a product, but how you could launch it is one main thing. And do not connect it with the commerce part. Why I'm saying this? Because satellite you have made, this satellite is fabulous. It is fabulous. It's having all the features required for your need. But this satellite is only useful when it is only useful if it is in space. Okay, if it is on Earth, it is not useful. And if you want to launch it into space, you required a launch vehicle. Okay, so when in the 1975 we developed the Aryabhat, we were able to develop the satellite, but we were not able to launch the satellite. That's why we took the help from our friend USSR, okay, which provided us their Cosmos 3M launcher, and the launch point, on the launch site was Kasputin-R. Okay, from there we launched the India's first indigenous satellite. All right. And if we talk about the USSR, now it's my question for you. What is the full form of USSR? Now it's a question. 10 seconds you have. And I'm going to count the seconds for you. And your time starts now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Time's up. So basically the USSR stands for Union of Sovereign Socialist Republics. Alright. USSR was formed in 1922 and was disintegrated in 1991. Alright, remember this thing. Thereafter, let's come to the year of 1980. In the year of 1980, after the Aryabhat, India has launched Bhaskara 1 and Bhaskara. Second, satellites. Okay. And basically, these satellites were launched for collection of data of oceanology and hydrology. Alright. Thereafter, another year was 1981 when we had launched Apple. Now, what do you mean by Apple? It's words Ariane passenger payload experiment. In short, known as the Apple. Okay. So basically, the Apple was India's first communication experiment to be launched in space by putting it into the GTO. Okay. So Ariane passenger payload experiment, in short known as Apple, it was India's first communication experiment launched in space by putting it into the GTO. Now you will ask me, what do you mean by the GTO? Okay, so first note down these details, then I will erase these things and now will tell you about the GTO. Okay, so I think that you have write them down. Now let's have a discuss over the GTO. So basically GTO stands for the geosynchronous transport orbit. And basically, what does it mean? It means that suppose whenever you are going to launch the satellite, in geosynchronous orbit, you could not directly reach that height up to 37,000 kilometers or 36,000 kilometers by your launch vehicle. Okay, so generally what happen? Launch vehicles put the satellite into geosynchronous transport orbit. All right. From here, the satellites uses own engines to push themselves above. It means that suppose this is the Earth surface. Okay. The launch vehicle deploy the satellite here. It is the GTO. And the satellite has to reach the point A. From GTO, the satellite will use its own engine to reach the A. So that's how the GTO system works. So the Ariane passenger payload experiment was basically India's first indigenous communication system, which was launched into the GTO. From GTO, it situated itself into the synchronous orbit. Okay, so remember this thing. Space exploration. ISRO has conducted various space exploration missions, including Chandrayaan-1. It was conducted in the year of 2008 to study the moon. And Mars Orbiter mission. Basically, Mars Orbiter mission. This was first conducted in 2013, where it was failed. Okay. Thereafter, in 2014, it conducted again and got succeeded, which made India the first Asian country to reach Mars orbit and the fourth space agency in the world to do so. Okay. Thereafter, the agency also having the future plans for interplanetary missions, including a purpose mission to Venus and a second lunar mission. Basically corrected. It is India's fourth lunar mission, named Chandrayaan-4. If you remember, it was the year of 2019 when the Chandrayaan-2 was launched by the ISRO, because Chandrayaan-1 was already launched in the year of 2008. In 2018, when we launched the Chandrayaan-2, basically we got failed. Unfortunately, we couldn't succeed. But we didn't lose hopes. It was the year of 2013 when we launched the Chandrayaan-3 mission, which made India's only country in the world to land on moon's south pole. Okay, and it is a proud moment for all of us. And India is the fourth country after the United States, Russia, thereafter China, and now the India, which have landed on Earth ever. Sorry, landed on moon ever, not Earth. Earth we are living on. Landed on moon ever. Okay, US, Russia, China, and India. In 2023, we had launched Chandrayaan-3, and nearly about 2025 to 2026, we will launch the Chandrayaan-4 with JAXA. JAXA is basically a Japanese space agency. Okay, so remember these details. Now the international cooperation. ISRO actively collaborates with space agencies and organizations from around the world promoting space-based research and exploration. As I had told you, we are going to launch with Chandrayaan-4 with the JAXA. Okay. Provides commercial launch services to international customers. We have discussed about the ACL in the previous lecture, which is a marketing and commercial arm of the ISRO. Okay. Upcoming projects, Gaganyaan mission, which aims to send the astronauts into the moon, and the development of small satellite launch vehicles, because right now we only having the PSLV and GSLV, which are for the big and for the heavy satellite vehicles, launch vehicles, sorry. But what if a person, or you can say organization or a country, or we itself want to launch only a small satellite? That's why we required a SSLV, small satellite launch vehicle. Okay. Now it's important to have a look upon the composition of ISRO. So the ISRO has a well-defined organization structure. It started with the chairman of ISRO. The chairman is the highest ranking official of ISRO and responsible for providing overall leadership and direction to the organization. Chairman appointed by the Government of India and key position in formulating and executing ISRO's vision and strategy. Remember who appointed the chairperson of the ISRO? Government of India. Okay. Thereafter, we have the Governing Council or the Space Commission. ISRO operates under the guidance of the Governing Council also known as the Space Commission. The Space Commission is the apex policy-making body for space activities in India, chaired by the Secretary of the Department of Space, who is also the chairman of ISRO. So you can say somehow the ISRO chairperson basically having the power in the Space Commission because he is the Secretary of Department of Space, which works under the Prime Minister office. Thereafter, we have the Department of Space, DOS in short. Department of Space is the administrative department of the Government of India responsible for country's space program. Secretary of the Department of Space is the chairperson of ISRO and leads the governing councils, as we have discussed earlier. ISRO Center. So ISRO has several centers and units spread across the country, each dedicated to the specific functions and tasks in the space program. Prominent space centers include Vikram Sarabhai Space Centers, VSSC, located at the Thiruvananthapuram, Kerala. Their location and their name is very important, mark my words. Satish Dhawan Space Center, SDSC in Sriharikota, Andhra Pradesh. UR Rao Satellite Center, URSC in Bangalore, Karnataka. Space Application Centers, SAC in Ahmedabad, Gujarat. Liquid Propulsion System Center, LPSC in Thiruvananthapuram and Bangalore. Thereafter, finishing with the ISRO centers, now we having the key functional divisions. ISRO is organized into various functional divisions, each responsible for specific areas of space, research and development. 3 divisions include Launch Vehicle Divisions, responsible for developing the PSLV and the GSLV because they are the launch vehicles. Satellite Divisions, involved in the design and development of satellites for various purposes. Spacecraft Integration and Testing Division, responsible for satellite integration and testing. Space Application Divisions, focused on applications of space technology for social benefits. Propulsion Complex, engaged in the development of liquid propulsion systems. Research and Development Laboratories, ISRO has several research and development laboratories working on various aspects of space technology and science. These laboratories conduct cutting-edge research and development in areas such as propulsion, materials, communications, and remote sensing navigation. So basically, compositions include the chairperson, thereafter the governing council, thereafter the units, thereafter the divisions, and thereafter the laboratories. So write down this flow chart. Okay. So students, basically in this lecture, we had finished the ISRO. In the next lecture, we will start with another important key national institution. Till then, just make sure you revise all the facts and figures we have discussed in this lecture so that you will be able to grasp the facts and figures in the another lecture. With this note, let's end this lecture and thank you.